course, you might be wondering what's the relation of the role play that I just had and the title of my talk today. So what we're talking about, the common thread here is the need for writing down my name so that I could win a prize, and the tool to bridge that gap was the pen. And in this case, what we're talking about, the demand for object-oriented programming principles, which lets us improve our applications in multiple ways. And the tools that deliver on those principles is the new, modern Java features. So the next obvious question would be, what is data-oriented programming? So the first point might seem silly, obvious, dumb maybe. Of course, you model data as data. Not really, because the data might be hiding in plain sight, or it might be a lot of work to model that data as data. Of course, we'll talk about how to do that. But once you do that, that reduces a lot of complexity in your system, which improves the efficiency of the system. When we talk about the efficiency, we could be talking about the performance, we could be talking about the maintenance, we could be talking about reading and writing the code. So of course, we would improve the efficiency in one or more dimensions. And when we're done with the first 2 points, we talk about the simplified data access and manipulation of the data. The queries that we're able to write, the code that we're able to write is easy to read, write, and maintain. So the modern Java features that I just mentioned, I would be covering 3 of them: records, sealed classes, and pattern matching. The other big question a lot of people ask me is why we are talking about data-oriented programming paradigm now, and are we kind of moving away from object-oriented programming in Java? Of course not. So these are 2 different questions, but as we know, Java is multi-paradigm. It is object-oriented, but we do have functional programming features in Java. And of course, we can incorporate data-oriented programming paradigm in Java as well, where we focus on data. And this is a result of the recent changes in how we develop our applications. We talk about microservices, we talk about more smaller units. And the new Java features that I mentioned, record, sealed classes, and pattern matching, they lower the barrier to achieve all of this, to model data as data, and to incorporate a lot of features in our applications moving towards data-oriented programming. Now, the big question, what is data? Silly question? Not so much. We could be talking about the obvious data. Let's say we talk about an application where we capture name and age of a person. We could talk about capturing other attributes in another application. We could be talking about a shopping cart, items, yes, obvious. And we could be talking about the JSON file, which of course is data. We could be talking about capturing a business item. Let's say we're talking about palette of 2 colors. So that could be obvious piece of data. CSV files, of course, they are full of data. What about the data that is not so obvious? What about the complex return type from a method? We know that Java doesn't have tuples, so we use other types like map, list, or other collection classes, or string types to return data. How could we model that as using records and the other features that I mentioned, and model that as data and not kind of move around assumptions or a lot of validations in other methods? What about string data, which might or might not have the delimiters? We could be talking about fixed length data. First 50 characters are for name, the following 50 are for address, and so on and so forth. Specifications like JSON, could we model that as data as well? We'll see. And before we cover the Java features, I really want to highlight one point, because whenever we try to learn new features, we focus a lot on the syntax of a feature rather than talking about its semantics, like what does it mean and how do we use it, which means the applications. I would like you to take a look at this image, which is of course image of a lion, and tell me other names or adjectives, nouns that you could use to hint that it's a lion. So you're not supposed to use the word lion, other words. Okay, big cat. Roar. Sorry? I didn't get that word. Leo. No, okay. No, you can't use it. Synonyms? No, okay. I take that, yes. Sorry? Okay. King of the jungle, yes. Anything else? Sorry? Main, yes, yes. So those are all good answers. And let's assume that align is one of the Java features that we're trying to understand. So if I kind of consider align to a Java feature, what we all talked about here was syntax. We talked about the color. We talked about it being a big cat. See, I already knew a lot of answers. Magic. So we talked about the main. We talked about it being brown in color, but that's all the syntax. What about the semantics? It's quite dangerous, right? Isn't it? And it's a carnivore. And what does that mean? How could you use that in your applications? You could use it as a pet to scare away your enemies. If you see one, you have to run away from it. That's one of the applications. And you don't let your pets around it because, for the obvious reasons, they would not kind of exist anymore. So this is, I know that we realized that quite late, right? So the applications are really important when we're talking about new Java features. So let's talk about the record feature, which is a new. How many of you are aware of the record feature in Java? I think that's a lot. That's good. So I'll quickly go through and not dive into a lot of details. So assume that this is a business domain that we're talking about. We're talking about encapsulating a palette of 2 colors, and we want to represent that as a record. So this is a way that we could do. And then, of course, there are other features like I could have handle the values which I want in the constructor. I could add constructors. So there are multiple constructors where I check whether they are not null, and then I assign the value. And these are multiple constructors. So this one calls this. I know this is a messy way, but a new JEP is on the way to kind of address this part. And then we could have generic records. We could have the other syntax part of record is that its components are, okay, so who can tell me? Are the components mutable or immutable? Sorry? Louder, a bit louder. Immutable, right. But what if the component itself is an object? Could we change the value? Let's say if it's a list, can I modify the value of the list? Of course, I cannot assign the list to another list. Yes, so I could change the components, and here you can see I could add a new item. But if I talk about changing or assigning the component to another value, then it will not work. So what does that mean? So we talked about a lot of syntax of records here. It's compact, it's a new type of data. We have the accessor methods which are generated automatically. The toString hashCode and equals methods, they are generated as well. So multiple points that we talk about the records. Now let's talk about the semantics. What does that mean? The type that we just saw, that's a concise way of creating a new type, and that means that the cognitive load that we have is lowered, which makes a lot of sense. If we compare these two pieces of code, of course, your IDE can generate all the code, but you would still have to read that code. And imagine you have a lot of data classes in your code, then it becomes much easier to quickly read through all the code. Now we talk about immutability. The data that you pass around in your multi-threaded application should be immutable. The values that you store in data, the data should not be a function of time. It should be what it should be when it started. So in that situation, records really help. The other one is because it generates default implementation of toString hashCode and equals. ToString is for the outputting the messages, but hashCode and equals, when they have default implementation, they could be stored and retrieved from collections without any issues. And this I think I probably covered in the semantics as well. So we could define value objects, data access objects, and entities with records. They are preferred in multi-threaded applications, and once we know what the semantics of a feature are, we could also know where to use it and where not to use it. So if we talk about applications like the Hibernate application, which manipulates the value of an entity after its creation, then records, it's not a good fit there. And so we also need to know where to use it and where not to use it, the limitations. And of course, I just mentioned it's easy to use with a collection framework. Now, for the sealed classes, the second type of feature that I want to talk about is the sealed classes, which lets us create restricted hierarchies. But why do we want to do that? Because let's consider this as an example. These are the Lego blocks. Let's say I am the Lego company. I would like to control what other blocks I create. I don't want anyone to kind of create the random blocks. I'm talking about the manufacturing unit. It could be the developer who just has random thoughts and they want to create a new character overnight. But I really want to create what inherits my base block. And this is one of the ways I could do that. So how many of you have worked with sealed classes or interfaces? Okay, a few. So this is a way, because if I define my class as a finite class, I cannot have any other classes which can inherit or extend it. But if I create it as a non-finite class, any other class could inherit or extend it. The only way that I could restrict it up until now was to reduce its accessibility. If I don't see it, I can't extend it. But in this case, I can have declarative extension. I can say the interface Lego can only be extended by these records. And in this case, I don't use if the implementing classes are in a different source file, I need another piece of information there which goes by permits clause, and then it is followed by the name of the classes that extend or inherited. But since this is in the same source file, that's okay to skip the inherit parts. So this is how I can restrict and control what other classes or interfaces can extend or implement my base class or interface. Now, the syntax we covered a lot. It uses the sealed keyword, the permits. The derived classes could be non-sealed, sealed, or final. In the previous example, the records are final by default, so we don't need to define them final because that's implicit. But if those are regular classes, we need to define them either as non-sealed, sealed, or final. And as I mentioned, permit can be dropped. And there are a couple of other points. I really don't want to deep dive into that part because we'll cover, otherwise miss the other important topics. The semantics is, what does it mean to define a sealed class? We're talking about modeling the choices. When I say that a Lego block can be inherited by 1, 2, 3, 4 kinds of other blocks, I am modeling the choices, what a Lego block can be, and that's exhaustive. That's finite. I don't say that it could be extended by any number of blocks or unknown number of blocks. As the developer of my base interface, I know exactly how many of them extend that, and the compiler knows that as well. So that's a big takeaway, because that could be used in multiple places in other code that we would see. As I mentioned, the compiler is aware of the available choice at the compile time. So that really means that it could doesn't has to work with the cases that don't exist. Applications, again, probably I've covered some parts. It's the clear code to handle polymorphism, because since the compiler already knows what the subclasses are, which method are called, and which classes, that's clear. And as I said, I don't have to think about not coding for not existing states. So this is a bit confusing statement. I couldn't find a simpler way to write this one. Okay, so let's understand with an example. So you are a parent, you have 2 children, and you walk into your home, and your spouse says, okay, so where is the gift for the elder child? And you say, okay, here it is. And then you say, where, and the spouse asks, so where is the gift for the younger child? And you say, here it is. And the spouse asks again, and what about the remaining? I said, what do you mean by that? We only have 2 kids. No, but still, the compiler won't say yes, you have to give the default part or the else part. What about the remaining? I said, that is not done. So this is what the seal classes helps. The compiler knows you have only 2 kids, so it will not ask for an else clause or a default clause, right? So, and now the third Java feature that I mentioned is about pattern matching that was delivered in 3 stages. The first one was pattern matching for instanceOf. The other one was with switch expressions and statements, and then the third one is the record patterns. So how many of you are familiar with using pattern matching for instanceOf? Okay, quite a few. What about pattern matching for switch expressions and statements? A few as well. And record patterns? Okay, just a few. So I have a couple of examples on this one so that we kind of come on the same stage before we move forward. Before that, I would quickly talk about what is pattern matching. So when I say what is pattern matching, what I'm trying to do is match an object against a pattern. So let's say, as I already said, an object against a pattern. So if my question is this object an animal? What could the answer be? Here I'm trying to match the type. So I could see a snake, a squirrel, fish is an animal, a bee, and zebra, and I have a tiger. What if I was looking at an animal that was striped with yellow and black stripe? I know it's a bit boring, so please stay with me. So now the answers would be this. So what we're talking about is testing an object against a pattern, which was the type, and then refining the pattern by adding conditions. And this is what we could do with pattern matching for in Java. It tests again a type, and then it could add conditions on the type. It could say if this object is a type of person, and then it could say person and person.age is greater than blah blah blah, or we could have multiple statements in that way. So let's start with pattern matching for instanceOf. This is how you might use instanceOf operator without using pattern matching. So I say an object is an instance of string, but the next line creates another local variable and then has a cast for this object for which we've already tested above. So we're kind of repeating what we said in the first line. So this could be, no, I have to show that in the IDE. Just a moment. Yes, so here we are. Now what I can do is I can replace this local variable with a pattern variable. Now here we are. Now this is a pattern variable, and if you see, the local variable is no longer required, because if the match is successful, the pattern variable is initialized and casted. So I don't need that extra line. You might think that it's just about removing one line, but don't let the simplicity fool you, because there's another example in which I can just follow the hints and I can replace this local variable with a pattern variable. And if I come here, my hands are freezing, sorry. simplify if else. So invert. Okay, now this is what I get after a couple of refactoring. What I'm able to get is a single line of code rather than that long block of code. What this means is that it opens other opportunities for us to refactor our code or to simplify it. Was that confusing? Okay. So let me show you another example, which would be the last one on this one. Pattern matching, where are you? Okay. Now there's another example in which I'll just follow the leads of the IDE. So now that the local variable has been replaced by a pattern variable, let me simplify the if-else by merging them, and there's another merging I could do. And now I see that there's a hint for, and I could do that as well. And I could also inline this variable. Let me say inline, still searching. Okay. Now, what does this mean is, now what I'm trying to highlight here is when I work with pattern matching for instanceOf, I could remove a lot of code, not just one line of code, and improve my code by refactoring it. So now let me talk about the other. Let me go back to my IDE, and where was I? Oh my God, did I? Slideshow in from current slide, will that work? Yes, it does work. Now let me talk about switch expressions and record patterns. I will not deep dive into a lot of examples because we are running out of time, and this is one example that I would like to highlight. It talks about seed classes, it talks about records, it talks about pattern matching for switch. Here we are returning a value. So pattern match switch expression means that you can return a value, and the case labels, there are patterns, they are record patterns and records which are generics. So here we are doing a lot of things. We are using switch expressions which use record patterns. So in this case, I'm using it to return values 1, 2, 3, and something, because when I try to use these variables, it kind of got a little overwhelming. So you could use the variable cheese here. What we are doing here is so records are used to encapsulate multiple components into one data type. How would you use those values? You would like to kind of disintegrate the structure. So this is what the record patterns do. And this line is a record pattern. You say that dish is the name of the type, which takes a generic argument this, and egg and cheese here are the components of record which are defined here. So that's how, if the value that is being passed to switch matches the object, matches the pattern, the values are extracted, sorry, what did I do? The values are extracted in these local variables, which are the pattern variables, and then you can use them. Now, we're done with covering this, the tools which I mentioned, the new Java features. I would quickly show you some examples of data-oriented programming. To start with, one that I mentioned was the CSV file. We see that often in our code where we have this data structure, where one of the structures could again be multiple data. So this is, let's first of all break it into tabular form. This is how it looks. As you can see, this one is multiple data, so I could define that this way as well. How do I define that as data? This is how I could do that. Now here, each data item or each row that I mentioned in my CSV file, that could be one type of data. And as I mentioned, because that's a concise way of defining a type, it's easier to define because of course we could define this data using the regular classes, but then we had the responsibility of defining the getters, setters, toString, blah, blah, blah. And even though we could use the IDE to do all that work, the probability is still less than 1.0. That means that we're not sure we will do or not, or the other co-workers will do or not. So that's how you could use pattern matching, sealed class, not pattern matching, records and sealed classes for modeling your data. And when you want to use the data that comes in this format in your code, you can use pattern matching for switch, or you could use it with pattern matching for instanceOf. That really helps you only deal with the data or the types that exist. And we're not talking about the kid which is not existent, so we don't have to buy kits for the kid who don't exist. So this is what I mentioned about using that data, the one that comes from the CSV file, because as I mentioned, the way we develop our applications is changing, and when we use the data that comes in the CSV file, when that enters our application, we want that to be validated before the larger application can use all that data, because we don't want inconsistent data to be used by our application. So this is one of the ways in which you could use that data in a very expressive, concise way, easy way I would say, which is easy to read and write as well. And I mentioned about the CSV file. This is applicable to the JSON data as well. The same CSV data could be defined like this or like this, where we break the middle part which had multiple data items. The other example could be ad hoc structures. The way we have been defining the older ones, we used to define the structures. So this is an example how we could define the structure. Here I have point, line, triangle and square. They all are structures, I would say, which again they extend the sealed class. And I could use that like this in one of my codes. Again, I am using pattern matching for switch, and because I'm using record patterns here, the values are, I could use these variables if this matches the pattern, and I could call the methods on them. The other one is the third example that I want to talk about is expressive hierarchical structures, something like this. So this is from one of the blog posts which was posted by Brian Gates, architect of Java. I couldn't resist showing this example to you, because this makes so much sense. Because when we talk about the JSON specification, we talk about a couple of types, which is the string, we talk about number, null, boolean, array, and object. All of this could be represented using your sealed classes and records. The fourth one, just 4 minutes. I will not take much time. So this is another example from the blog post that I mentioned from Brian Gates. How many of you have issues with the optional class? I mean, you hate it, not like it. Oh wow, just few of them. Okay, so so Brian says there's a better way of defining that class. Probably if we would have the new features now, probably we could have defined, the Java architects might have defined the optional class this way. And this one's for you. We know that we have been passing around strings to pass the configuration data. Would you, I know you would see a lot of code that passes the strings around. Would you like to model this as data or not? So that's a question for you to think about and answer. And I know I skipped a lot of points, a lot of details. So I have on the Java language features and other things, I have a lot of posts which kind of covers more details. So if you want to kind of go through those blog posts or videos, feel free to do that. So we are at the end of the session, if you like the session, so that's conditional, then you can scan the code and post your feedback or comments on it. Remember, that's conditional. If. Thank you. We are towards the end of the session. If there's any question, I'm ready to take them.